from the quiz. You see the first question was finding the domain of the function would be repeated again, but this time we're going to find where the function is going to be continuous, which is going to be the same thing. Okay, so you explain it. The first one is a polynomial. Okay, for x to the fifth minus 3x is a polynomial, so the domain is all real numbers. In the case of the continuity, it's the same thing. You see, it's a polynomial, it's continuous everywhere. We're going to check it when we get to the review. The second one is a rational function. You always should check the zeros of the denominator. If it is factorable, it is factorable, x squared minus 9, you get 2 factors. So if you let the denominator equal to the 0, that gives -3 and 3. So you have to remove those -3 and 3. So your domain would be 3 portion, 1, 2, 3. Negative infinity to -3, -3 and 3, and 3 and positive infinity, and we have to use the parentheses. Okay, in the case of the continuity, would be this function is continuous everywhere except at these 2 points. Okay, similar one. The third one, when we get to the radical function, we have 2 cases. Okay, the case with the even index and the case with the odd index. You have to explain it. Index 5 is odd. You know that when the index is odd, you can remove it. The function inside is a polynomial. So the index equal to the 5 is odd, so this function is defined everywhere. You have to mention the reason is the index, okay? Some of you didn't explain this one. So that's how we answer number 1. Any question? So it would be repeated again, but with the continuity version. Now the piecewise defined function, very popular one, you will get one again. The function is defined by different formulas. So when you want to find the limits, you check to see which part are you going to use. You've got to read it carefully. You see this is x goes to 3 positive. 3 positive means x is greater than 3. So you have to use the second part. Some of you missed it because you use x equal to 3 negative. Read it carefully. Sometimes they switch it. In this case, they may ask for the 3 negative first, 3 positive then, or otherwise. Just look at this one carefully. So that was 3 positive. So x is bigger than 3. This is your function to be used. Radical x plus 13, limit after radical x plus 13. You substitute 3, that give you 4. Radical 16 is equal to 4. Okay, a couple of you, for example, somebody give me radical 16 equal to the 3.32, which is not true. Radical 16 is 4. Then that would be the right limit, the left limit, x goes to 3 negative, x is less than 3. So use the first part now. And then you substitute and you get 10. Now the right and the left limits are different. You have to tell us. You see, that's it. They are different, and so the limit of the function does not exist. Okay, so you have to give us a reason why this limit does not exist. If they are the same, that same number is going to be your limits. Okay, so that's going to be part C. And the part 4, the evaluation. F of 3. You go back to see where you can put x equal to 3. You are going to use the first part. If this equality sign is missing, in that case, f of 3 is undefined. So be prepared for this type of cases. But in this case, we have the equality, so we have to use the first part, and the value of the function is going to be equal to the 10, and then we're done. Okay. What's that? Is there a difference of meaning between this equality and implies? Yes. You see, the implies you can, instead of and so, you can use implies. But the equality, you see, the inequality must be here. So instead of, you see this one, I say and so. You say this is not equal to, then you can say that would implies. That would implies that this limit does not exist. So the way some of you wrote it is, you wrote limit of f of x goes to 3 is equal to the limit of f of x goes to 3 negative, and is not equal to the f of x goes to 3 positive. So the limit does not exist. Your expression doesn't make sense. So the expression must be the right and the left limits are different. So the limit of the function does not exist, because that's a theorem that we have. Be careful, these are a small point, but it's important, to be precise. So, and f of 3, we substitute, get the result. So be prepared for it. And we may give you something that you get the equality. So you get the equality again here. You say it's equal to, and equal to, for example, 5. And so the limit of f of x goes to 3 would be 5 too. Or you may try to find f of 3, but equality is missing. If equality is missing, you have to tell us f of 3 is undefined. Okay, so there are two other possibilities of this problem. So that's number 2. It's I told you, very important problem. We give one on this test, then we are going to forget it for a while, but when we get to the final, we give you this one again, because that's one of the problem in calculus that's important. Now, most of you missed this one. Okay, we give another one. Sketch the graph of the piecewise defined function. Remember, we talked about it. For the graphing, you have to graph each part separately. And you got to be careful. There is a restriction here. So for the first part, restriction is x less than 1. You pick two numbers. The first one must be 1. And the other one is less. So I put the 1 because we estimate. Don't worry that you don't have equality. You estimate. So x equal to 1, that give you 1, 1, and the 0, negative. You go back and you check this one. You see, that's it. You get the 1, 1 first. 1, 1 is your restriction, the end of your function. Since there is no equality sign, you are not going to have the end. So this must be empty. Okay, everything up to the 1, up to the 1. That's why we pick the 1 and then we forget it. Okay, that's the first part. The second part, x greater than or equal to the 0, again, that's the starting point. You have to pick the 1 and something else. If you don't pick the 1, your graph is out, because you have to tell us what would happen around the 1. So 1 and 2. You are going to go back, you see you get 1 and 4, 1 and 4 above this one. You have the equality sign, so you make it solid here. And you have to go to the right. So that would be the domain of the graph of your function. They ask for the limit when x goes to 1. You see, because it's a 2 portion, you have to check the right and the left limits. Okay, that's one. Some of you didn't check it. You check only one side and you claim that the limit is 4. No, it's not. Since it's a piecewise, you must know that you have to use the right and the left. So we pick x equal to 1 negative, we arrive at 1. Because x is less than 1, use 2x minus 1. X goes to 1 positive, x is greater than 1, use the other part. You see 1 not equal to 4 again. So the right and the left limits are different. That implies that the limit of the function when x goes to 1 does not exist. Okay, so this is how you answer these type of questions. Any question? So go back if you missed the graph.
Was that 4?
Right. Yes.
Okay.
That, which one? It's number 3. Number 3. The problem number 3, but the right and the limit, yeah, it's a 1 and 4. 1 and 4 are not, it's the same, so the limit does not exist. Okay, that's number 3. Number 4, part 1, x go to -1, you substitute that, give you 0, 0. Okay, 0, 0, you know that there is a common factor. That common factor is x plus 1. So put the x plus 1 on the top and the bottom, you see. On the top, that is x plus 1. So you match this one. You see, that's a 2x squared. So you need a 2x times x, 2x squared, and you have to match a -1. This is a positive one. Positive 1 times the -1 would be -1. Done. And the bottom one is x plus 1 times x. You simplify it, you substitute to get it 3/4. Some of you try to use your algebra. You see, in algebra, you break the middle term here because you want to do the grouping method. And so you break this one into the 2x minus x, then you do the grouping. But you didn't finish your grouping. Forget about that algebra. Use this method. Easy method. Easy method. Because you try to use the grouping, and in the meantime, you didn't complete it, so you didn't get the correct answer. Okay, this one, the other one is you must have the limit. We talk about it. Because when you have the limits, you can simplify it. If you don't write the limits, you cannot simplify it. Okay, so that was the point that some of you missed it. So that's it to rehab. I'll give you another one. Then the second part is the radical one. Okay, most of you did it right, which is very good. So x goes to -2, we get the 0, 0. So the common factor is x plus 2. X plus 2 is already here. You have to multiply the top and the bottom by the conjugate of the top. Conjugate, this would be a positive 2. Okay, nicely, the top is just a special FOIL method. A square of the first minus the second, x plus 6 minus 4. You simplify it, you must get x plus 2. So you eliminate x plus 2, so that would be 1 over radical x plus 6. You substitute, and the final answer you get a quarter. Okay, so most of you did it right. Any question? So you don't have this type of problem in your book, but this is not going to be the case that you shouldn't know them. They are very important problem. Okay, so this is a special limit for the 0, 0. We repeat it again. That was number 4. Number 5 was easy. And most of you, at least the part 1, you did all right. It's just a polynomial, you know that. The limit of the polynomial, you replace the x by -1. But you must be careful about your algebra. You see 4 times -1 cubed. You have to put it inside parentheses and apply it first. -1 cubed would be -1. So that give you, okay, that give you a -4 plus 1 minus 1. So you simplify to get a -4. Some of you missed the algebra here. And for the absolute value, we talk about it. X goes to 5 positive means the inside is positive. You drop the absolute value. X minus 5, x minus 5, we get a 1 right away. If x goes to 5 negative, you drop the absolute value, you replace it by opposite of x minus 5. Means you get negative x minus 5. So the result would be -1. So there are 2 cases. Okay, any question? So that's a number 5. Number 6, easy problem. You want to find the m so that the right and the left limit to be equal to each other. You have to find the right and the left and let them to be equal to each other. So limit of f of x, x goes to -1, negative, x is less than -1. Use the first part, substitute, simplify, 2m plus 4. Some of you missed this one here. So you arrive at 3 plus 2m here. No, it's going to be 3 plus 1, which is 4. So 2m plus 4 for the first part. You find the limit when x goes to -1 positive, so that gives you the limit of the second part. The second part, 2x minus 4m, so that gives you -2 minus 4m. So the first part and the second part must be equal to each other. You let it equal to each other and you solve it for m. M equal to the -1. Again, some of you use the wrong method that I told you that don't do it. So what you did, you didn't use any limit for us, okay? You let this, okay, the first part and the second part to be equal to each other, and you substitute x equal to -1, and you get m equal to the -1, but you didn't get the, you probably get at most 2 out of 4. So make sure don't repeat it on the test. In that case, you get 0 because we explain it. You find the limits. You see, the limits must be equal to each other. Okay, so that's one. So study this one again. Just redo your quiz. Just then you compare it with whatever we have over here. Any question? Now you have a similar one on that practice one. So let's go to the practice test number. Okay, number 1. So I'm going to review this one. Practice test number 1. We give you 11 questions and there are 11 topics here. So that's it. No surprise. So I'm going to pull out that. You do have it on a, so I cannot shade it with you at the same time with what I'm going to do. Okay, so this is going to be practice test number 1. This is it. Question number 1. Question number 1, again, is a piecewise defined function. You see the function is given to you. And as I told you, let me give you one. X squared minus 4 divided by x minus 2. This is when x is less than 0. And x squared minus 4 divided by x plus 2 when x is greater than 0. It's a piecewise defined function and it's partitioned at 0. So they ask for the right and the left limits. The first part, read it carefully. You'll be given what is the limit of f of x. Okay, when x goes to, the first part is 0 positive. That's it. You know that x goes to 0 positive means x is greater than 0, so we have to use the second part. So it's going to be equal to the limit of x squared minus 4, x plus 2, when x goes to 0 positive. The number is 0, so you substitute 0 minus 4, 0 plus 2. So that gives you a negative 4 over 2, which is a negative 2. So that's going to be the right limits. Any question? So very similar to the quiz that we have. But read this one carefully. It's positive, 0 positive. They may switch it. They may give you 0 negative first. So be careful. Okay, the second part, they ask for the left limit of f of x. X goes to 0 negative. 0 negative means x is less than 0. So the function to be used is going to be the first part. So the limit of x squared minus 4, x minus 2 this time. X goes to 0 negative. The number is 0. 0 minus 4, 0 minus 2. So that gives a negative 4 over negative 2. The result, 2. That's it. Right and the left limits are different. So the limit does not exist. So for part C, again, you explain it. You see, you explain that the limit of f of x, x goes to 0 positive, is not equal to the limit of f of x, x goes to 0 negative. Implies or, and so the limit of the function at 0 does not exist. So that's how you answer the part C. Any question? Part D. They ask for the f of 0. Any suggestion? Which part are you going to use to get the f of 0?
It's not defined.
It's not defined. Very good. Because you don't have equality sign. So we cannot use the first part or we cannot use the second part. So f of 0 is, this is it, undefined. Except, this notation if you like. Or f of 0 does not exist. Both of them is going to be the same thing.
Excuse me, Professor, I just want to make sure.
Yeah.
So you will be able to use one of those if it was like bigger or equal to sign?
If there is equality sign, you see.
Okay. Yeah.
There is no way, because you want to plug in, you see.
Yeah.
So you must have x equal to 0. You don't have it, so this means we cannot do it. So f of 0 is undefined or does not exist.
Okay. Thank you.
Okay, so this is it. You have one in your take-home one. Okay, you check that one quickly. So that's number 1. Number 2 is like the problem that we talk about it. You see the opposite or the converse of this one. It's a 2 parts. Okay, so it's going to be number 2. Number 2, we do the part 1. The part 1 again is a piecewise defined function. You want to find the m. So f of x is equal to f of x equal to the x squared minus m with the condition that the x is less than equal to 1. And it's a negative x squared plus m when x is greater than 1. Okay, so what do you want to find? You want to find the m. You see, that's a question. Find m. So that the right and the left limit at 1 to be equal to each other. Limit of f of x, x goes to 1 negative, to be equal to limit of f of x, x goes to 1 positive. That's it, like in your quiz. So what we're going to do, you are going to find these limits. Remember, find this limit first, let them equal to each other. That gives an equation in, in M. Then you find the M. You have to find the limits, remember, not just letting the function to be equal to each other. Okay, so there you are. Limit of f of x goes to 1 negative. So you know that the 1 negative means x is less than 1. Use the first part. Limit of x squared minus m. X goes to 1 negative. The number is 1. You substitute. It's going to be 1 squared minus m, which is 1 minus m. So that would be the left limit. Okay, question. Check the other part. So the limit of f of x goes to 1 positive. 1 positive means x is greater than 1, so we have to use the second part. So it's going to be limit of negative x squared plus m. X goes to 1 positive. Again, the number is 1, so it would be 1. You see, if you want to write it down as a negative 1 squared plus m. You square first, then the negative sign. So that gives you negative 1 plus m. Okay, now you let the first and the second part to be equal to each other because it's given to you, see? It's given to you that they are equal. So 1 minus m equal to negative 1 plus m. You have to solve for m. So you can collect the m's to the right or to the left, doesn't matter. Usually collect to the left. So we already got the negative m. We subtract this m, negative m. So you get the negative 1 and the negative 1. Okay, so that make it into the negative 2m equal to the negative 2. So m would be 1.
Why wouldn't it be 1 minus negative 1?
Which part?
Because you did negative m.
I subtract the, you see, I subtract the m here. So that gives me negative m minus m. And over here, I subtract the 1. Negative 1 minus 1. You have
But
to.
but 1m is like positive, so why wouldn't you put positive m? So negative m plus m, positive m.
You subtract it, it's on the other side. Negative m on one side, positive m on the other side. What are you going to do? You have to subtract it to get everything on one side of the equation.
I think the question was, why can't you just add the ones that are negative so you end up with 2m equals 2 rather than dealing with the negatives?
So why not this one? Both of them are the same. Both of them are the same. If you want to do that one, this is your solution. 1 plus 1 equal to the m plus m. So that gives you 2 equal to the 2m. So that gives you 1 equal to the m. So m is equal to 1. But we collect the variables to the left. So it's the same thing. Okay, any question? So what I did, I just collect the variables to the left, negative m minus m. You don't like it, you want to do that one, do the other one, doesn't matter. You arrive at the same answer. Okay, so that's the first part. You find the m like your quiz. Okay, make sure you get the operation all right. And you have to find the limits. You find the limits first, and then you let them equal to each other, then you solve for them. That's a part 1. The part 2 of this problem is that piecewise defined function. At this time, we want to graph it again. Okay, so that's so that was a 2a, and this is going to be the 2b. Okay, 2b. 2b, the function is going to be like the one that we did have. This is your function. It's a 1 plus x. X less than equal to 1. Okay, 4 minus x when x is greater than 1. Okay, they ask you to sketch the graph of this function first, And this time they ask where this function is going to be continuous. It's like finding the limit that we did it for the quiz. So first we have to graph it. You see, you get two portions. You see the first portion is going to be y equal to y plus x with the restriction of x less than equal to 1. Okay, take care of this one first. You need the two numbers. That is x, and this is going to be y plus 1 plus x. The restriction is 1, so you must start with the 1, less 1 and 0. Okay, is x less than equal to 1, so you must start with the 1 and something done. Okay, we substitute together. If you put x equal to 1, so that gives 1 plus 1, which is equal to 2. And if you put x equal to the 0, so that gives 1 plus 0, which is equal to 1. Okay, let's do the other part too, then we graph both of them. So that's the first part. The second part, y equal to the 4 minus x, the restriction of x greater than 1. So your t table for this one is going to be, this is your x, and this is going to be y equal to the 4 minus x. Again, you must start with 1 because you have to estimate it around 1. Okay, that gives 4 minus 1, which is equal to 3. Then something bigger, like 2. So that gives 4 minus 2, which is equal to 2. You see, there are these tables first, and then go and sketch the graph. Any question? So your operations must be around the 1. Okay, around the 1, you see 1, 0, 1, 2. Because this is bigger than 1. So you have to pick the second number to be greater. This is less than 1. So you have to pick the second one to be less than 0, okay? So we are going to sketch the graph. This is it. So we graph the first part. We have 1 and 2, 1, 2, 1, 2. So this is going to be 1. Then you check to see if it's covered, because this is the end of the graph. There is equality sign here. So this means this would be covered. It's a solid. Okay, and you have a 0, 1, and this is 0, 1. You graph it, and you know that you have to go to the left because x is less than equal to 1. Any question? So you have to have your partition point to identify the end of your graph because this is the end. So we pick the 1 and the 2 since there is equality sign. So the end point is also covered by your graph. Okay, now we go to the second part. The second part that gives 1 and 3. The number is different, so there are going to be two pieces. 1, 3, that's a 2, 3. Okay, 2, 3. So this is going to be the point here. Then there is no equality sign. So this point is not going to be a solid point. You have to make a hole. Remember, you cannot have two solids at the same time. You cannot have two solids point at the same time. Okay, so this would be empty. Then you have a 2, 2. This is it. This is 2, 2, 2, and that was a 2 here. So that gives you another point. You connect this time, you go to the right. Okay, you go to the right. This is going to be the right. Okay, this is it. This is the graph of the function. For the continuity from the geometrical point of view, you see, we talk about it. You see at 1, this graph is 2 pieces. So this means this graph is not going to be, this function is not going to be continuous at 1. Okay, it's not continuous at 1 because at 1, you see, we get 2 pieces here. So this is going to be the result from the, you see, this is a negative infinity and positive infinity, but you have to remove the 1 here. Remove the 1. If you graph it and you get 1 piece only, you see if this is going to be the case. In this case, this function is continuous for all real numbers. Okay, you can find the right and the left limits, they are different. You see the right and the left limits are going to be different. The function is not going to be continuous, but we would like you to get it from the, from the graph, because we already talked about it. Okay, at 1, this function would be separated. So this function is not going to be continuous at 1. So the function is going to be continuous in this portion. So you have to tell us that f is continuous, because they ask you determine where the function is continuous. You say that f is continuous. F is going to be continuous on this interval. Okay, you can call it D if you like. The interval of a negative infinity to 1, union with 1 and positive infinity. And you're done. Any question? During the quiz, I asked you to find the limit of f of x goes to 1. Because at that time, we didn't have the continuity. But now we have the continuity. This is it. Some people even, they try the limit of f of x goes to 1 to confirm it. Because, you know, the left limit is going to be 2, and the right limit is going to be 3. So 2 and 3 are different. So this function is not continuous at x equal to 1. But since we graph it, we would like to have a look at the graph and tell us where the function is going to be continuous. Okay, any question? So that's it, just sketching the graph again as you did it before, but that last part that we asked for the limit, but in this case, we just look at the continuity. When a function is continuous, the graph of the function, remember, is one piece only. There is no separation over here, but you have the separated part. So this means your graph is partitioned at 1. So this function is continuous everywhere except at 1. Okay, that's it too. Any question? Now those special limits that you did it, and there are going to be again here. Okay, and just 2 cases that we talk about it. There are 3 cases over here. You know, we just give you the polynomial type or the radical type. So that's going to be number 3. And number 3, we want to find each limit. Find each limit. These are going to be a special limits. It's going to be the type that you get a 0, 0. Okay, so we have 2, the part 1. The part 1, your limit is going to be limit of, so we have the x squared minus x minus 2. And the second part is x squared minus 7x. Okay, it's a 7x plus 10. You want to find this limit when x goes to 2. You substitute first. You may not get a 0, 0. If you substitute 1/2, you're done. But we substitute to see if it is going to be 0, 0. Okay, that's going to be the 1. You get the open circle when the points are removed. That's it. So somebody asked when we get the open circle. You get the open circle because you see the first part and the second part are separated. You look for the continuity. The graph is continuous, it's one piece. It's not one piece, it's 2 pieces. So at 1, you are going to get this one. Okay, and on the graph, we talk about it. We put the solid if it's equal to. And we get an empty if this equality sign is going to be, is missing. Okay, so let's go back.
Wouldn't the
Yes.
domain actually be negative infinity to 1 with a bracket instead of parentheses because it's less than or equal to?
Domain, yes. The domain is all real numbers. But this is not the domain of the function. This is the domain of the continuity of the function. You see, there is a difference between these two for this problem. You see, the domain of this function is all real numbers because you have the equality here. But what is the domain of the continuity of the function? You see, because they ask for in the previous problem, you didn't have the continuity, so that's why we ask for the domain. But over here, you got to be careful. Yes, the domain of the function, you may, if you don't like this D, you can drop it if you like. not to be confused. The function is going to be continuous in this interval. It can be the same as the domain of the function or not. But the domain of this function is all real numbers because the function is defined at x equal to 1. But the question is this function continuous? If this is going to be continuous everywhere, then you can cover the 1. But it's not continuous at 1, so that's why we don't cover it. Okay, any question? Make sure you know the difference between these two that I'm talking about. Okay, you are not talking about the domain of the function. You are going to talking about the domain of the continuity of the function, where the right and the left limits are the same. But domain of the function is all real numbers because this is it. You have the equality sign, okay? But this function is defined for all real numbers, but it's continuous at all real numbers except 1 because it's partition at 1. Okay, any question? So let's get back to these limits, special limits. So we substitute to see that it is going to be equal to the 0. To confirm it, you see 2 squared would be 4, minus 2 minus 2, so that gives you 0. Over here 2 squared would be 4, and that's 7 times 2, 14 plus 10. As you can see, it's going to be 0, 0. Okay, what's the message for this one?
Common factor.
Common factor. What is the common factor?
X plus 2
No, not plus 2.
minus 2.
X
Minus 2. Yeah, x goes to negative 2. Okay, x goes to 2, so x minus. Just remind you that x minus 2 is a factor. That will help you. So we can factor it quickly. Okay, is a common factor. Whatever the number is, you move it to the other side. So x minus 2 is a common factor. Okay. So go back, rewrite it. So this is it. It's a limit of x goes to 2. You see, you have already one factor. That will help you to do it quickly. That's x minus 2. And that's x minus 2. So your job is to find the other factors. You see? For the other factor, you check this one first. This is x squared, so xx would be x squared, the number. This is a negative 2. So you have a negative 2. Negative 2 times what would be negative 2? Negative 2 times a positive 1. Don't bother about the other part. Automatically we get it. For the bottom one, again, this is x squared. So this is x. You need another x here to make it into the x times x to be x squared number. Number is 10. This is a negative 2. Negative 2 times what would be a positive 10. Negative 2 times a negative 5 would be a positive 10. See, that's how quickly we get the factoring part. You don't have to use the grouping method that you try. Okay, so there you are, the common factor out. So the leftover is going to be the limit of x plus 1, x minus 5. X minus 5 when x goes to 2. Now substitute. That gives you 2 plus 1, 2 minus 5. So that gives you 3 over negative 3. The answer would be a negative 1. Okay, so that's going to be the limit of that fraction. Any question? So that's a polynomial type. We need one for the radical type, part B. The part B is the limit of x goes to 2 again. And this is going to be radical x plus 7 minus 3. And that's x minus 2. Again, you substitute to confirm that you get a 0, 0. If you substitute here, 2 and 7 would be 9. Radical 9 would be 3. Okay, so this is it. So that gives you radical 2 plus 7 minus 3, and that's going to be 2 minus 2. So this would be 0. Radical 9 would be 3. 3 minus 3. So that gives you 0, 0 again. So the common factor again is going to be x minus 2 because x goes to 2. So x minus 2 is going to be a common factor. Okay, this is going to be a common factor. But we have to create it on the top. Since we have the radical expression, we have to remove the radical. You know that you multiply by the conjugate of the radical expressions. So we start it over. That's x goes to 2. See? And that is the original one. X plus 7 minus 3. So you have to multiply by the conjugate. And this is going to be the conjugate, x plus 7 plus 3. Okay, you do the same thing to the bottom. X minus 2 times that's conjugate part, radical x plus 7 plus 3. You FOIL the top is a special FOIL, square of the first minus the square of a second, and you are not going to touch the denominator, okay? So it's going to be equal to the limit of x goes to 2. The top is going to be radical x plus 7 all squared minus 3 squared. The bottom one would be unchanged, x minus 2 times radical x plus 7 plus 3. You keep the limit, remember it's the limit. So we square the radical, we remove the radical, they give us x plus 7, but that would be minus 9. So it's equal to the limit of x goes to 2 on the top. We stay with the x plus 7 minus 9. Down the bottom as is, it's x minus 2 times radical x plus 7 plus 3. You continue on the top. Remember, you need x minus 2. So 7 minus 9 would be negative 2. That's you are looking for. So that gives x minus 2 on the top. And this is going to be x minus 2 times radical x plus 7 plus 3. Now we got the x minus 2 on the top and the bottom. You see, that's it. Eliminated it. That gives you 1. So it's going to be limit of 1. And that's going to be radical x plus 7 plus 3. Now x goes to 2. You substitute. So that gives a radical 2 plus 7 plus 3. It's a radical 9 plus 3. It's going to be 3 plus 3, which is 1, 6. The final answer. Okay, so that's the famous special limits and exactly the one that you got on the quiz. So we give you 1, 2 parts again. Any question? The part C, you don't have to worry about it. It's just a complex fraction. You know, you don't have complex fraction in your book, so we are not going to check it. Okay, so we stay with it. It's nice to know, of course, you know, these type of problems, but we are not going to use it. So that would be question number, okay, question number 3. Any question? So these are the one that more or less you did before on the quiz, okay? So the rest are going to be new for you. The rest are going to be, we talk about the domain of the function. Remember, we give you 2 questions on the domain of the function. Now we are going to, instead of the domain of the function, we ask for the domain of the continuity, where the function is continuous, okay? You know that if the limit of the function and the value of the function happen to be the same, the function is going to be continuous. But we give you a theorem, remember? Like the polynomials are continuous, the product, the quotient of the continuous function continuous, so you are going to use all of them to get these numbers. Only the piecewise defined function is going to be different. So we give it 2 questions on the continuity, which is the same as that 2 question, question number 1, and the last one that you did have on the, okay, on that quiz.
Professor, I have a quick question, sorry.
Yes, what's question?
How come we didn't cancel out in the first where there is a square root of x plus 7 plus 3 on the top and bottom in red?
This one,
Yeah, how come you didn't cancel it out there instead
we
of like,
multiply, no, we multiply it. We
Uh-huh.
multiply in order to remove the radical. This is, we did it intentionally.
yeah, oh, okay, I get it.
Yeah, if you
Yeah.
cancel it, you get back to the origin. No, no, we did it intentionally, remember?
Yeah, all right, sorry,
Remove
I
that
confused. Yeah, okay, thank
Okay,
you.
so that's it, number 3. Now we get into the 4. Okay, there are a kind of 4 types of function for the continuity. It's the same as the limit, the domain of the function, but we are going to ask where the function is going to be continuous this time. Okay, that's it. You have to give us the result in interval notation. We want to determine where the function, that's it, determine, and you can use that theorem that we talked about. Just if it's a piecewise defined, you have a little bit. There are 2 cases that you need to do something extra for us, but the rest going to be easy. Determine where the function, okay, function f is going to be, let's say it must be a function. Determine where the function, okay, the given function. The function is continuous. Remember, continuity means the graph of the function is just one piece, or if you find the right and the left limits happen to be equal to each other. But we use the theorem that we have. Okay, there you are. This is how we're going to answer this type of question. Part 1. Part 1, f of x equal to x cubed minus 2x plus 3. That's the first one. What type of function is this one? What type of function is x cubed?
Polynomial.
Polynomials. And remember, we have a theorem. The theorem that every polynomial is continuous forever. That's it, you're done. But you have to mention it, okay? So this is how we're going to answer this part. You answer that f is a polynomial. F is a polynomial or a polynomial function. And so it's continuous. The graph is one piece. It's continuous everywhere. Everywhere, if you like, on, you can write the domain if you like, it's the same thing. Negative infinity and positive infinity. Do that. Any question? You have to mention that f is a polynomial. Even if you write negative infinity, positive infinity, we question you because that's a theorem. That's a theorem that on the quiz, we ask only for the domain of the function. You write negative infinity, positive infinity, that's fine. But over here, they ask where the function is continuous. So it must be a polynomial to be continuous, okay? You can say f is a polynomial, that's it, and it's continuous on this interval, and you're done. That's a case 1. Any question? So select domain. Case 2. Case 2, g of x is equal to 3x plus 1 over x squared plus x minus 2. You see the top is a polynomial, 3x plus 1, it's continuous. The bottom one, x squared plus x minus 2 is a polynomial, it's continuous. We have a theorem that the quotient of 2 continuous functions is continuous. It's continuous everywhere except when the denominator is 0, like the domain. So you have to factor this one first to see how many numbers are going to remove, okay? So it's like the one we did before. We factor the bottom one first, so that's going to be solution. G of x is equal to, that's a 3x plus 1. And you factor it, that give you x. You need 2 numbers with a product of 2 and a difference of 1. And the number is going to be 2 and 1. So that gives you x minus 2 times x plus 1. Okay, that's your factory. The number would be 0 at 2 places. You see, if you like, this is x minus 2 times x plus 1 equal to the 0. So that gives us x equal to 2 and x equal to the negative 1. So these are the bad numbers. Okay, These are going to be your bad numbers, so you're going to exclude them. So this is going to be your number line, negative infinity to positive infinity. Then you have to remove these two numbers, -1 and the +2. So we have two holes, if you like. So this function is going to be everywhere continuous, except when x is equal to 2.
Wouldn't that give you negative x?
Sorry?
Wouldn't that give you on the bottom x squared minus x minus 2?
Is it negative x?
Yeah, I'm saying, so like on the denominator for x squared plus x minus 2, I think the way you factored it, if you multiply that together, wouldn't it be x squared?
I know what it, thank you. Yes, you are right. You are right. This would be, I just have to switch. Yes, thank you. This is a +2, very good. So, okay, it's going to be +2, and that's going to be -1. Okay, so this would be a +1, so I have to switch those. And this is going to be a -2, thank you. Okay, so this is going to be a -2, -2, and the +1. Sorry about that. Yes, very good. So this is it. So the function is going to be continuous. You see, g is continuous. G is going to be continuous on this domain. On the domain of, okay, -infinity to -2. And you remove it, so it's going to be parentheses, not bracket. Union with a -2 and 1, and the union with 1 and positive infinity. Okay, it's like for this function, it's like the domain that we, you know, that we talk about it. Okay, so this is it. Any question? So for the rational function, as we did it before, you see, for the rational function, everything is all right, except when the denominator is 0. When the denominator is 0, you get some holes. It is separated. You see, when you graph this function, it's going to be 3 portions, 1, 2, 3. So at those partition points, the function cannot be continuous. So that's why we get a parenthesis. Okay, so that's going to be part B question. The part C is the same, but some people, they miss 1 point. So that's why we want to make sure you are not going to miss it. It's going to be x minus 4 over x squared minus 16. And the same thing, we have to factor the bottom one, which is easy to factor. Okay, so it's going to be solution. We factor it is h of x, so we get the x minus 4 on the top. And this would be x minus 4 times x plus 4. You see, the difficulty is some people, they simplify it. No, you cannot simplify it now. Okay, you find you do the job first. Your job is continuity. It's not simplification in this case. Okay, so make sure don't simplify it, because you have 2 factors on the denominator. So we have the x minus 4 this time times x plus 4 equal to the 0. So that gives us 2 numbers to remove, x equal to 4 and x equal to the -4. If you cancel it out, then you think that you have to remove 1 numbers only, which is not the case. Okay, so sometimes they give you this one to check to see if you are going to make that mistake. Okay, so this is it, the number line. Again, you have to remove those bad numbers. The bad numbers are going to be -4 and the +4. Okay, so 3 portion. So again, h is continuous. So h of x is going to be continuous. Okay, it's going to be continuous on this domain. The domain of the function. -infinity to -4, union with the -4 and 4, and the union of 4 and positive infinity. Okay, again, you have to have parentheses, because you know that at those points, the denominator would be 0, and if the denominator is going to be 0, your function is not going to be continuous. Okay, any question? So you have all the possibilities really for this type of function, the rational function. Even you have the next one is the case that the denominator sometimes is not factorable. You know that? Okay, are you done with this one? So again, it is another interpretation of the setup function that we introduced at the beginning of the course, and now you know why. So part D, very much a similar case. Something special about this one: x over x squared plus 9. What is special about this one?
You can't factor it.
You can factor it, yes, x squared plus 9. So when you cannot factor it, you know that the domain would be all real numbers. So this function is continuous everywhere. Okay, it's not a polynomial, but because the denominator is not factorable, so it's behaved like a polynomial. Okay, so solution. Remember, you can factor x squared minus 9, not plus 9. So x squared plus 9 is not factorable. Okay, not factorable. And so when it's not factorable, this means it's never 0. You cannot make it 0. Because you need something like a, you see, something like a -9 plus 9 to make it 0, but you won't get it. Okay, so the number line stay the number line. So the function is continuous, f is continuous everywhere. F is continuous, if you like, on this interval. -infinity to positive infinity. No, no restriction, no bad numbers. Any question? So that's going to be the rational function. The tricky one is a radical function. You know that in the case of the radical, we are going to have to focus on the indexes of the radical. So you may have the even index or you may have the odd index. In the case of the odd index, everything is nice because the domain would be all real numbers. But in the case of the even index, you have work to do. Okay, so we got to be careful about this one. So we go to the part E and we get one of them. Part E is this function, g of x is equal to the square root of 9 minus x squared. You see, as we did it before, inside the radical is a 9 minus x squared, is a polynomial, it's continuous. But the question is, can you take this one out of the radical? You look into the index. What's the index of this radical? Index of the square root. Yes, we have Paul and all true. The square root. Index of the square root is 2. Say a square root, a square 2. So the index is 2 here. And 2 is even number. So when it's even, you got to be careful. You cannot have a negative numbers. So you have to impose this restriction. Solution. Say the index of this radical, 2 is even. You have to move on, go on. So what is the conclusion? Index is 2. Now you say that, and G is continuous. G is going to be continuous. G is continuous when 9 minus x squared is greater than or equal to 0. You see, that's your extra job. Any question? Because it's a radical square root. You cannot have radical -4, for example. The square root of -4 doesn't make sense. Okay, that's why you have to impose this condition. We did this one before. You solve it. The quickest way to solve is solving for x squared, remember? There is a negative x squared. We divide both sides by -1, but we switch the sign, reverse the sign. So that gives x squared less than or equal to the 9. Then we take the square root, radical x squared, the radical 9. Okay, remember what's the radical x squared? Radical x squared.
Absolute value of x.
Excellent. Absolute value of x. Remember, it's not x, it's not positive negative x. It is absolute, okay, absolute value of x. Okay, now we have the absolute value. Remember, we put the number line. Negative infinity to positive infinity. This is the origin, 0. 3 to the right, a positive 3. 3 to the left, negative 3. Now it's less than, less, you go inside. So the domain of the continuity is between negative 3 and 3. So it's going to be negative 3, comma 3. There is no fraction. So you are going to use the bracket. Okay, when it's a fraction, you cannot have the negative 3 and positive 3. But over here, there's no fraction. It's a radical. It's a radical. If you put x equal to 3, that gives 9 minus 10, which is 0. Radical 0 would be 0. So you have to use the bracket over here, okay? So this is going to be the domain of the continuity. Okay, so we can say that the G is continuous. G is going to be continuous. Continuous on this interval. Bracket, okay, close interval of a negative 3 and a positive 3. Any question? So you have to be careful about the index. This is true if it was 4, 6, 8, the same story, the same solution and the same solution and the same answer. Okay, this would have sometimes if they switch these two, your final answer would be different. So that's the idea of the next part. You see, you have all the possibilities. So the part F is K of X is equal to the, again, a square root of the x squared minus 2. Same thing, index is 2. So you have to work to do, okay, it's just similar one. So the index of the radical, 2. 2 is an even number. Okay, 2 is even, and then we are in trouble. And K is continuous function. It's going to be continuous when or where x squared minus 2 is greater than or equal to 0. Same thing. Solve for x, move the 2 to the other side, x squared greater than or equal to 2. Take the square root, radical x squared, radical 2. Radical x squared is going to be absolute value of x, greater than or equal to the radical 2 this time. See? The previous one was less than. This is greater than. So what's going to be the final answer? Again, we get the number line, negative infinity, positive infinity. 0 is going to be home. Now radical 2 to the right, a positive radical 2. Radical 2 to the left, and negative radical 2. But where are you? X greater than. It's not less. Since it's not less, you are not here. So the complement is going to be you are either here or you are going to be here. See, that's the difference between these two problems that you got to be careful. When it's greater than, so you are going to be between negative infinity and negative 2, or between radical 2 and positive infinity. But it was less than, it would be between negative radical 2 and the positive radical 2. So the domain would be negative infinity going to the negative radical 2. That's going to be open close bracket, union with the radical 2 and positive infinity. That would be the domain of the continuity of this function. Any question? So make sure the difference between these two for the last part. And it's okay, you make it a radical 2. You don't have to use your calculator. You write it down as a radical 2. Okay, so that's the even index. When it's odd, it's free. It's like the one on the quiz. So we have one with the odd to finish it. And this is all the possibility of a continuous function. So the part G is the easy one. part G, the function is h of x equal to cube root. Cube root of x cubed, okay, minus 3x plus 7, like on your quiz. You say the index is 3 is odd. When its index is odd, you don't have to worry about, because you can have all sorts of numbers. Inside is a polynomial. It's continuous, whatever. See, solution, it's an even index that is, causing trouble. So the index 3 is odd. That's it. So what you have inside polynomial, and it's continuous everywhere. And so h is continuous everywhere. H is continuous everywhere on this interval, domain of a negative infinity and positive infinity, and you're done. Okay, so if the index is going to be 3, 5, 7, you see that's a best case, because there is no restriction and you get it right away. But when the index is when it is even, as you saw over here, you may have to do a little bit more to get it. Okay, so that's going to be the continuity of the continuous function. There is one more case, and that's when we get the piecewise defined function, and that's a number 5. I give it a break now, then we come back, we do one more example of a continuity, and then the rest, that famous 5 question on the derivative of the function. Okay, and we finish it. So it's 8:24, 10 minutes, we come back and we continue. Okay, see you in 10 minutes. Okay, we're going to continue. There is one more group of the function that you have to check the continuity. It's a piecewise defined function. In the case of the piecewise defined function, you have to check the continuity at the partition point only. Because at the partition point, you may have like the one that we did. You may have two separated pieces, so the function is going to be continuous everywhere except at the partition point. Or sometimes you may get one piece, so the function would be continuous forever. So I give you one from each. So that's going to be number 5. So the above group, a kind of polynomial type, and this is just a piecewise defined one. Okay, so let's check part 1. I just give you two different cases. You see part 1, this is the function f of x is equal to the 2x plus 3 when x is less than equal to 4. And you have 7 plus 16 over x when x is greater than 4. And you want to check where this function is going to be continuous. You see, the difficulty is just this partition point. Everywhere else, it's continuous. So what I'm going to do is, as we did it for all the other problems, you are going to find the right and the left limit at 4. If the right and the left limit happen to be equal to each other, this means the first portion and the second one would be attached to each other. So this function is continuous forever. But if the right and the left limits are different, means at this point, at x equal to 4, there is a break, there is a gap. So the function would be continuous everywhere except at 4. Okay, so that's going to be easy when you know what we have to do. So we find the limit of f of x when x goes to 4 negative. 4 negative means x is less than 4, so the function to be used is the first part. So that gives you 2x plus 3, x goes to 4 negative. The number is 4, so it's a 2 times 4 plus 3. So that gives you 8 plus 3, which is equal to 11. Okay, so that's a left limit. Check the right. Limit of f of x, x goes to 4 positive. 4 positive means x is greater than 4, so we use the second part. So it's going to be the limit of, remember the limits, 7 plus 16x, x goes to 4 positive again. You substitute, so that gives you 7 plus 16 over 4. 16 divided by 4, that gives you 4. So it's going to be 7 plus 4, 11. You see? So the first part and the second part are the same. So this means, you see, this means the continuity would be everywhere. If these two numbers are going to be different, you remove the 4, the partition point. But in this case, they are the same, so you claim that f is continuous. F is going to be continuous everywhere, continuous on this domain. Negative infinity and positive infinity. Okay, in calculus, if you want to do anything to a piecewise defined function, anything, limit, continuity, differentiability, you have to check the one-sided one. Because a little bit to the right and the left, you have two different functions. So you have to check to see if they are going to be connecting to each other. At this point, this is the case. If you graph it, you see there is no break because 11, 11. But it's going to be 11 and 5, for example. This is it. There is a gap. Okay, so this is the one that you won't get the gap. Any question? Let's get the one that they give you two different numbers, and that's part D. So we give you one, it's going to be either case. Let's check this one to see if we get two different numbers. For part D, this is your function. F of x equal to the negative x to the 4th. Okay, plus 3. when x is less than equal to 2. And it's x squared plus 9 when x is greater than 2. You see the partition point is 2. So check the right limit and the left limit at 2. If they are the same, this function is continuous everywhere. If they are not, you have to remove that partition point. Okay, are you ready? There you are, solution. We're checking the limit of f of x when x goes to 2 negative. 2 negative means x is less than 2, so the function to be used is the first part. Negative x to the 4 plus 3. X goes to 2 negative. Substitute, remember the number is 2. So it's going to be negative 2 to the 4th plus 3. Make sure the algebra is okay. We do the power first. 2 to the 4 would be 16. There is a negative here, so that gives me negative 16 plus 3, which is a negative 13. So that would be the left limit. Make sure you do the algebra. You see, you raise it first, and then you apply the negative sign. The limit of the other side, limit of f of x, x goes to 2 positive now. 2 positive means x is greater than 2, so this is the function. So it's going to be limit of x squared plus 9 when x goes to 2 positive. Substitute, the number is 2. 2 squared plus 9. 2 squared plus 9, 2 squared would be 4. 4 and 9 would be 13. You see? They are different. This is a negative 13, and this is a positive 13. Some people, they miss a sign somewhere here, they arrive at the 13, 13, which is not. Okay, so what's going to be the conclusion? Negative 13, not equal to 13. So this means, you see, like the one that we did. If you graph it, it's 2 pieces, and there is a hole in between. So this means what will happen to the continuity. You have the number line. So you have to remove the partition point, remove the 2. See? We remove the 2. So the function is going to be continuous on what? F is continuous. F is going to be continuous on this domain. Domain of negative infinity and 2. Remember, you remove it, so it's parentheses. Union with 2 and positive infinity. That would be the domain of the continuity. Okay, so these are the possibilities for the piecewise defined function. If it's not going to be piecewise, it's going to be one of those cases that we discuss for number 4. But if it is a piecewise defined function, you have to worry about only the partition point. Are you going to connect them together, or is there going to be a hole in between? In this case, we get 2 different numbers, so this means they are not going to be connected at this point. So this point is where the function is going to be separated. Okay, just make sure that you get the numbers to check this one. That's going to be fine. It's a piecewise defined function. You see, piecewise defined function. If you want to do anything in calculus to the piecewise defined function, for the partition point, right and left limits, because it's less than or greater than. So let's see. You check the right and the left limits. Okay, any question? So that's a continuity. We give you 2 questions, and these are the possibilities of the functions. In your quiz, we didn't ask for the continuity, we asked for the domain. It's very similar, but that piecewise defined one is different, that you have to check the right and the left limits, and we already checked all these limits for you. Okay, question? Now the derivative of the function. For the derivative of the function, what you are going to do for us? We give you a function to differentiate, a couple of functions. You have the power rules, okay? You use the power rules to differentiate it for us. That's the one problem. The other problem would be application problem. Remember, tangent line problem, horizontal line problem, and the rate of change. So 4 questions on the derivative of the function. I did all of them the other night for you, and then we are going to have a repetition of those problems, okay? So you can't miss it, and again, you have your take-home one to check. Okay, so this is the first question on the derivative, number 6. You want to find the derivative of each function. Find the derivative of each function. You need only one formula. This is it. Power rule, remember? The derivative of x to the n, action of differentiation. What is action of differentiation? Exponent times coefficient, or you bring the exponent down and down, x to the power, 1 down. That's n would be n minus 1. That's it. You need only this formula for the next 4 problems. Any question? That is what? That's a power rule. So we can have x squared, 2x. X to the 5th, 5x to the 4th. We can have a negative power, remember? X to the negative 3. We can have a rational power, x to the 1/2, x to the negative 3/2. So these are going to be the candidate. So we give you something that you know you have a couple of maybe radicals or the quotients. Okay, so there you are. One problem, 2 parts. The first one, y equal to x to the 5th minus 5x to the 2, x squared, plus 6 over radical x plus 7. That's it. First thing to do, you see, you can do it to the power only. If there is any radical, you switch it. If the x is down the denominator, remember, you move it up. So you have to rewrite this one first. Okay, solution. We rewrite it's going to be y equal to x to the 5th minus 5x squared plus 6. Now x to the, since it's a radical x, would be x to the 1/2. It's down the denominator. You have to move it up, so it's going to be x to the negative 1/2 plus 7. This is how we rewrite it. Any question? So we give you the formula for the radicals. Radical x would be x to the 1/2. You have to move it up because you have only this formula. You see, you don't have any other formula. So we can only do the powers. Now we are ready for it. Y prime, derivative. Action of differentiation. Exponent times coefficient, and they reduce the power by 1 unit. X to the 5th, 5, x to the 4th. Done. Okay, next one, minus. Exponent times coefficient. 2 times 5, 10. X to the, that's a square, that's 2. 2 minus 1, which is 1. Next one, plus. You see, exponent times coefficient. This is a fraction. We write it down, then we simplify. 6 times. 6 times a negative 1/2. X to the negative 1/2 minus 1. We talk about negative 1/2 minus 1 would be negative 1 minus 2, which is a negative 3/2. Okay, if you don't like it, it's a negative 1/2 minus 1. Would be negative 1/2 minus 2 over 2. Okay, which is a negative 3/2. A quick way to do it, it's a negative 1. You know, just think about the negative sign is a sign of the top one. So it's a negative 1 minus 2 would be negative 3, negative 3/2. Derivative of a 7 is 0, remember? Derivative of a constant function is 0 because this is 7x to the 0, if you like. So you have to simplify it, only simplify the coefficient for us, not the power. So y prime would be 5x to the fourth minus 10x. 6 half, you simplify it by 2, that give you 3, and that give you 1. So it's going to be minus 3 x to the negative 3 halves, and you're done. You don't need to do any extra operation with the algebra. You can do it for yourself, but this is the calculus part. Okay, I know that in your book they change the x to the negative 3 half into the 1 over, what's that, the square root of x to the third. No, you don't have to do it. So that's going to be the final answer. Any question? So make sure that you do the algebra part all right. Okay, the calculus part is easy. The algebra part is switching these radicals. It's x to the half, you move it up, x to the negative half, and then you bring the power down, 6 times negative half, x to the negative 3, and the derivative of 7 is 0. Okay, so that's the first one. Second one, again, we give you something mild, but the other one, a couple of radicals, like this one. Y equal to 4x cubed, because you are going to have a polynomial types in the next 3 problems. So that's why we are not going to give you a polynomial for this part. 5th root of x to the third plus 12 over the 4th root of x. You see, this is a kind of most involved one. Not complicated, but you got some algebra involved that you have to take care of. So you need the rewriting. You have to rewrite this one. And this is done the denominator. You change the radical, then you move it up. Okay, are you ready? Solution. Rewrite it. It's going to be 4x cubed minus x to the, what's the power for this one? 5th root of x to the third. Any suggestion? When you switch it, x to the which power? 3/5, yes, 3/5, that's it. So x to the, you see, x to the 3/5. So it's going to be x to the 3/5, done, plus 12x to the, is the 4th root of x, would be x to a quarter. Based on the denominator, you move it up, x to the negative quarter. You see, I give you the formula, this is it, I repeat it again. And that was the n root of x to the m is going to be x to the m over n. Index goes down the denominator, and the other one is 1 over. If you have 1 over, let's say n root of x, you move it up, it's going to be x to the negative 1 over n. Okay? Or if I, let's just give something easier. So this means if you have 1 over x to the n, you move it up, x to the negative n. So this is 2 formulas that you need to change these radical format, if you like, okay? So that's a 5th root of x to the third would be x to the 3/5. Over here is going to be x to a quarter first, and then you move it up, make it to the x to the negative quarter. Now we are ready to take care of s, y prime. Exponent times coefficient, 3 times 4, 12. 1 down, x squared. Next, 3/5 times the negative 1 would be negative 3/5. X to the 1 down. Negative 3/5 minus 1 is like 3 minus 5. 3 minus 5, that gives negative 2. Negative 2/5. Done. Okay, plus. Exponent times coefficient, 12 times a negative quarter. X to the 1 down. Negative quarter minus 1 is like negative 1 minus 4. That gives negative 5. Negative 5 quarter. Okay, make sure you get this algebra all right. Simplify the coefficient if it's possible. So y prime is equal to the 12x squared. It's a minus 3/5, x to the negative 2/5. 12 divided by 4, that gives you negative 3. So minus 3x to the negative 5/4, the final answer. You see, this is the question on the finding the derivative of the function. We are not going to give you polynomials because the next 4 problems, you have polynomials only. So make sure to do the algebra all right, okay? There's going to be a couple of radicals that you have to use that formula, okay, to be able to get through it, to get these numbers. Okay, any question? So that's a question on the derivative of the function. Now the easy part is going to be the applications. The first one is the tangent line problem, very straightforward problem. And it's going to be a polynomial type. So question number 7 is equation of a tangent line. Number 7, tangent line equation. Now you have to use the following formula for the equation of a line: y minus y1 equal to the m times x minus x1. That is the equation of the line. The slope, this is calculus. The slope is derivative. It's going to be derivative of the function at the given number. Okay, we talk about it. The slope of the slope of a tangent line. Okay, the slope of a tangent line would be just derivative of the function. So it's a 2 steps problem. You see, it's going to be a polynomial type, just part 1 and the part 2. Part 1, this is the function x to the 4th minus 5x cubed plus 2. We want to do it at the point x equal to 2. It's 2 steps. Step 1, we need a point. X is given to you. X equal to 2, you drop it into the function to get the y. Step 1, where is the point? Solution. Where is the point? So your x of the point is 2. Substitute in the function. Make sure you get the algebra all right. 2 to the 4th minus 5 times 2 cubed plus 2. 2 to the 4th would be 16. 2 cubed would be 8. 8 times 5 would be 40 plus 12. Okay, you double check your algebra. 2 to the 4th is 16. 2 cubed is 8. 8 times 5, 40. So that would be what? It's going to be 18 minus 40, which is a negative 22. Okay, now you have a point. You may call it the point P. Coordinate 2, comma, negative 22. So this is x1 and the y1. That is step 1. Any question? So we just substitute the numbers. Step 2, the slope. So we're going to find the slope. This is calculus. Slope m is derivative of the function f prime at 2. So this means you are going to find the derivative of the function and you plug x equal to 2 in the derivative. That number would be the slope. And it's a polynomial, okay? It's not going to be anything else. So find the y prime. Okay, so there you are, y prime. Okay, what's the y prime? Any suggestion? Give us the derivative of this function. Who wants to try? Y prime.
Is it for y prime equals 4x cubed minus 15x squared?
Excellent. That's it. Yes, very good. Exponent times coefficient, the power, 1 done. 4x to the third. 3 times 5, 15 minus 15, x to the 1 done squared. Divided of 2 is 0. That's it. Very good. So replace x by 2. Find the y prime. It's going to be 4 times 2 cubed minus 15 times 2 squared. Carefully apply the algebra. 2 cubed would be 8. 8 times 4 would be 32. Minus 2 squared would be 4. 4 times 15. 4 times 15 would be 60. Yes, that's it, 60. Now we are going to subtract it. If you subtract it, this is going to be a negative. Okay, the negative, I think it's 28. Yes, that's going to be 28. But this y prime, so y prime equal to the 28. But this y prime is m, the slope. The slope, negative 28. That's it. Any question? So it's a straightforward operation. You put x equal to 2, whatever number is inside the function that give you the point. You differentiate it using the power rule. It's going to be a polynomial. You differentiate it using the power rule and you replace the x by 2 again in the derivative. At that number, they give you the slope. There you are. Now we are ready for it. You see, you have a point, 2 and negative 22. So that's going to be the x1, y1. And we have the m, which is a negative 28. Write the formula, substitute y minus y1 equal to the m times x minus x1. Substitute y minus y1 would be y minus negative 22. M of negative 28 times x minus x1, which is a minus 2. You have to simplify it. So negative would be positive 22. And you distribute this one, negative 28x plus, that give you 2 times 8, 16, 56. Negative 2 times negative 8. So you subtract it. So subtract 22, 28x plus 56 minus 22. So y would be negative 28x and plus, what is this one? So that give you 434. So this is going to be the equation of a tangent line. Any question? So that's a tangent line problem. Okay, it's a nice one. And the part B is again a polynomial. Part C and the D, you are not going to worry about it. We do this one later on. Because that was a part of the review that we did for the summer. So these are not going to be given to you. So we get to when next quiz. So part C and the part D. We need 2 rules for differentiation, and we'll see it when we get to quiz number 2. Okay, so that's a tangent line problem. Any question? Don't miss it. It's an easy problem. Now, what's going to be the next one related to tangent line? Remember, we talked about horizontal tangent line. A line is horizontal if the slope is 0. But this is calculus. The slope is derivative, f prime. So in order for the tangent line to be horizontal, f prime must be equal to the 0. So this is the idea of the problem number 8, a little bit of algebra. Okay, I told you those critical values or critical points. That's a number 8. We give you 1. And we usually give you one problem, part 1 and the part 2. The part 1 would be tangent line equation, and the second part is going to be this one. Okay, so in this case, you are going to find horizontal tangent lines. To answer this problem, you have to do this one for us only. Solve f prime of x equal to the 0 for x. Because they are going to ask you, find, you see, that's the instruction of the problem. instruction of the problem is find all values of x where the tangent line is horizontal. The tangent line is horizontal. This slope must be 0. This slope is f prime. So this simply means find the f prime. Let it equal to the 0, solve for x. That part, let it equal to the 0, you got to be careful. There's going to be an equation. You may, most of the time, factoring. If you cannot do it, you may use quadratic formula. Okay, again, it's a straightforward problem. So let's try one of them. Part 1. The function is f of x equal to the 2x cubed plus 9x squared minus 60x plus 4. It is going to be a polynomial because you cannot do anything else. That's it. Find the f prime. Let it equal to 0. Solve the equation. Try factoring. If you cannot do the factoring, you may use quadratic formula, but all of them can be done by the factoring method. Okay, are you ready? So for the solution, I just repeat, you are going to solve this equation, f prime of x equal to the 0 for x. So the key is f prime. Here's the f prime. What's the derivative of this function? Suggestion, exponent times coefficient, you reduce the power by 1 unit.
6x squared plus 3x minus 10.
6x squared plus,
3x.
no, not 3x.
No?
You have a 9x
Maybe
squared.
18x.
Oh, yeah. Sorry, that was my factored version.
Okay, 18x and
Minus 60.
minus 60. Yes, very good. That's it. See, exponent times coefficient, 3 times 2, 6, 6x squared, 2 times 9, 18, and 1 times 60, and x disappear, and derivative of 4 is 0. Very good. Let it equal to 0, use factoring. So it's going to be 6x squared plus 18x minus 60 equal to the 0. All of them are divisible by 6, so we factor out the 6. Okay, so that gives us x squared plus 3x minus 10 equal to the 0. We factor the inside, it's going to be 6 times. We need two numbers, product of 10 and a difference of 3. And the numbers are going to be what? It's going to be x plus 5 times x minus 2 equal to the 0. 2 times 5 is 10. They give you some nice number to be able to factor it. Okay, yeah, so it's factors 1, 2, 3, 6 equal to the 0, never. But x plus 5 equal to the 0. That gives you x equal to the negative 5. X minus 2 equal to the 0. That gives you x equal to 2. There you are. So you have two, you remember we call it critical values for future. So you are going to have two horizontal tangent line because you have two numbers for the x, okay? At x equal to negative 5 and x equal to 2. In future, one of them give us the maximum, the other one will give us the minimum. That's going to be the one. Okay, so again, it is straightforward problem. You must know the idea that you have to solve f prime of x equal to the 0 and then the factoring. Okay, the other, part are easy. You can do it yourself. Any question? That will take us to the application problem. Okay, application question. Application question, remember, that's the idea of the rate of change that we talked about the other night. So we have 3 over here. Usually your case is business. So we give you the business type. So I put 2 over here. One is business, the other one is otherwise. But we usually give you 1 or maybe 2. Okay, let's check. Remember, derivative of the function is rate of change. We want you to explain it to us. What does it mean? So we are going to create something from everyday life problem and something from business. Okay, let's check. Or just one. It's a straightforward problem, don't miss it. So what's the number 9? You see a company total sales in millions of dollars, it's given to you. See S of T, a function, sales function. It's a point. You got to be patient, you may have some decimal number, so don't miss it. See S of T is what? 0.03 T cubed plus 0.5 T squared plus 2T plus 2, 2T plus 3. You see what is this? This is total. Okay, that's a total. The sales of the company, sales in millions dollars. Okay, million of dollars. Okay, dollars, T months, after T months. Okay, T months from now. After T months, if you like. After T months. So the T is the time is in month and the S of T is in dollars. So what we're going to do, we ask you 2 questions only. We would like you to find F of 10, S of 10, sorry. S of 10 and S prime of 10. That's it, and explain it. Okay, and if you like, explain its meaning or their meaning. Just write a brief verbal interpretation of these results. Okay, so you substitute, be patient, is a decimal number. Nicely use your calculator to find the number and then make a statement for us. Okay, there you are. What is S of 10? You substitute. S of 10 equal to what? Is a 0.03 10 cubed plus 0.5 10 squared. Okay, 10 squared plus 2t 2 times 10 plus 3. Carefully find it. It's not difficult. It's going to be point. You can use your calculator if you like. This is going to be 1000. And this is going to be 100. I multiply this one, it's going to be 20 plus 3. Okay, I'll multiply these 2 together. So that give me 3000. I have 2 decimals. Okay, 2 decimals, so it's going to be 30. And you multiply this one, that give you 500. We have 1 decimal to get 50. Okay, and that's a 20 and the 3. So I think it's going to be 103. Okay, so S of 10 is going to be what? It's 103. Remember, it's in million. So it's going to be $103 million if you like. Okay, it's going to be 103. The million you have to multiply by, okay, 10 to the 6 if you like. But it's going to be million. Okay, that's going to be $1 million. That's S of 10. Any question? What does it mean? There's something nice about it. Remember, S of T is going to be your sales, okay, after 10 months. Any suggestion? S of 10 equal to $130 million.
So would it just be, okay, go ahead.
Yes, suggestion.
Oh, so after 10 months, the company has sold $103 million.
Excellent. That's it. Yes, very good. After 10 months, after 10 months, okay, the company sales, if you like, or some company sales. Okay, that's it. The company, or just the sale. Company sold. What's that? $130 million. Okay, or the sales of the company after 10 months is going to be what? $103 million. Okay, any question? That's part one. That's exact. Now the derivative, S prime. S prime is going to be estimate. You have to find the S prime of t carefully. S prime of t equal to, you see, be careful to find the derivative of the S prime. Exponent times coefficient. You see, you may use your calculator. 3 times 0.3. So that give you 0.0, okay, 0.09 t squared. That's the derivative of the first part. Again, 2 times 0.5. 2 times 0.5 would be 1. I write it down for you so that you know what's going on. It's going to be 2 times 0.5 bat t. And derivative of 2t would be 2. Derivative of 3 is 0. Okay, so the S prime of t, carefully, is going to be 0.09 t squared. 2 times 0.5 would be 1, so that would be 1t plus 2. So this is going to be S prime of t. Any question? So the example would be from everyday life. So you may have some decimals. Double check it with your calculator. Make sure you get it, you get it all right. Okay, so this is going to be the case. Now they ask you to find S prime of 10. Now you substitute S prime of 10. It's going to be 0.09 times 10 squared. Okay, and this is going to be plus 10 plus 2. Okay, 10 plus 2, and if you simplify it, it's going to be 0.09 times 100, and that's a 12. So it's going to be 900, 2 decimals, going to be 9 only. Okay, 9 plus 12, which is going to be 21. So S prime of 10 is going to be in dollars. Okay, remember this is $21 million if you like. Okay, so that gives you S prime of 10. Okay, so we just substitute. Okay, that's it. 10 squared would be 100. So the 100 times 0.09 would be 9. 9 and 12, you're just going to be 21. Okay, so we want to make a comment now. Any suggestion for the comment? When we get the S prime of t, that is going to be the case. And the next month, no, a little bit better. The expression, any suggestion? Good one. Remember, S prime is a prediction. It's a prediction and it's going to be an estimate. S prime of 10. Any suggestion for the rate of change? The function is the sales function. So you're talking about the rate of change of the function. Okay, Parker, you said that the next additional month will make approximately 21 million or more in sales. Okay, somehow you are right. Something better to express it. Yeah, it's, but you can give us a better expressions. Okay, put them together. Your idea is correct. You see, that's at this level, you see, this is the prediction. Remember, you start with this expression that, after 10 months, You see, after 10 months, this is the rate of change in sales. Since it's positive, you're making more money. How much? What is the rate of the money that you're going to make? You are going to make what? You are going to make $21 million per month, if you like, from now on. You see, after 10 months, after 10 months, you have to start with this expression. After 10 months, the sales of the company, okay? That is going to be the case. Okay, after 10 months, the sales will be increased because it's positive, will be increased at the rate of, you have to use this expression because it's derivative, at the rate of what? $21 million, $21 million per month. For the for the present time, this means next month. You see, this is 10 months. Okay, after 10 months, this is the money that you are going to get at each month. So the next month is going to be, when the next month is coming, so your sale would be increased. How much more money are you going to make? $21 million. Okay, so the derivative, you see that S10 that you find, that's just an exact number. But the derivative is future from now on at this time up. Since the prime is positive, you're making money. So after 10 months, the sales of the company will be increased. If you get the negative number, it would be decreasing. So in this case, it's a positive number. So after 10 months, the rate of change, if you like, the rate of the sales will be increased, or the sales would be increased at the rate of $21 million per month. So that's going to be the rate of change. Okay, any question? So that's going to be the one, the number 10 and 11 are the one about the cost function. I can post the solution for the 9 and 11 for you. It's the same thing. It's a cost function that we did the other night. So it's the same thing. They ask you to find what's going to be C of at 2 different levels, and then they ask you to describe it. When it says sales, you see the sales of the production, the cost of the production of the 10 cars or 100 cars, like the one that we did the other night. You can say an additional, as an additional unit. But when they put it to this type of ideas, you should be ready for it, really. Okay, we talk about it. The concept is important to understand it. Otherwise, the function is very easy. You see, even if you don't want to make a comment, because the comment would have 2 points, for example, out of 10. So you should be able to do the rest of the operation. Okay, so the rest of the operation, the function is given to, they ask you to find that one number, just substitute. Or the second part, they ask you to find the derivative at some numbers. So you should be able to find these two. Just the last part, you make sure that you get the something nice to express. That's it. I post the solution for the 10 and 11 for you. They are very much similar to each other. But we give you one problem of this type. So you have the 9, 10, and 11 to practice. But we give you one to put them together. Otherwise, no surprise, this is a very nice review. Okay, it's a bit not too much, but if you just relax and take it one by one and go over it and then do your take on one, then you should be able to get through the one that we are going to give you on the test. Okay, so the topics are here.